get? What did you get here? Quick. If you implement it, what did you get? Next step. I am asking that dou P mu Ig plus RT ln xi Tn bar divided. So it will be Big. That's very correct. How will you get it? Dou P mu Ig Tn bar and in dou P of mu Ig Big. That is RT by correct? Which is RT by P. So now we are getting answer one after another. We are so curious at the beginning of the class. We are getting this. First we got Vi bar Igm equals to Vi Ig. Next is Si bar Igm. We can do this quickly because method is ready to us. Si bar Igm is what? Si bar Igm is what? Minus dou mu Igm by dou T Tn bar. This mixture, ideal gas mixture, it will be minus Si bar Igm. It will be Si bar Igm Si bar Igm equals to minus dou mu Igm by dou T Tn bar. It will be
SIIG minus RLN XI.
yes sir. SIIG minus RLN XI. All of you got it? Yes or no? Yes. Okay, excellent. Gi bar Igm. That you have already got it. That is already there. So there is no interesting stuff here. Already you know the answer. There is no interesting stuff here. It is already got from the definition. No challenge here. Okay. Next is Ui bar Ig. There is a challenge here. How to proceed? Same way for the pure substance. Pure substance, how do you do that? We had that, you know that G equals to U plus Pb minus Ts. G equals to U equals to G minus Pb plus Ts. G minus Pb plus Ts. So you can write Gi bar Igm minus Pbi bar Igm. Then we have minus Ts I bar plus. Okay, no problem. Pb bar Igm is nothing but Pbig. Bi bar Igm is Big. RT, Pbig, Ig is RT. Gi bar Igm, you know the answer. So what will be the thing? Case here? Not Devayan, not Rahul. Sorry. Abhijit, now. You can get me the answer. It's very easy, nothing. Right? Result, sorry. I will take your help later, right? Anybody else? Any hands? Yes, madam. UIIG, that's all. UIIG. What else is left? HI bar IgM. HI bar IgM. Quick. HI bar IgM. Quick. HI bar IgM. HIIG. I am not doing for AI bar IgM. You can do it quickly. Keep it. AI bar IgM. Do quickly. Once I remove the stress things in the blackboard, when I do it, and it will say some difference will be there, like GI bar IgM and GIG, and that can be obtained from this because A means U minus TS, right? So AI bar IgM is nothing but UI bar IgM minus TSI bar IgM, and of course you know that IgM is nothing but UI IgM. SI bar IgM is slight difference is there. RNXi, it will be like RT. It is like similar kind of expression you get. AI bar IgM is nothing but AI Ig plus RT and Xi. You can prove. Okay, very interesting thing we have done. So now you can see that delta H IgM will be 0, delta U IgM will be 0, delta S IgM cannot be 0 because Si bar IgM is not equal to Si IgM. Delta G IgM will not be 0 because Gi bar IgM is not equal to Gi IgM. Okay, so we have to find out. Now we will be showing something very interesting. UIGM generally we write as summation I equals to 1 to n ni ui bar IgM. It will be nothing but I equals to 1 to n ni bar ui Ig. Right. Next, we can write HIGN in a similar manner. I equals to 1 to n. Sorry, it should be C component. Check it out. Each component has number of nodes n1, n2, n3. Okay, so I equals to 1 to C, not n. Ni Hi bar IgM. Or I equals to 1 to C Ni Hi Ig. VIGM summation I equals to 1 to C Ni Vi bar IgM summation I equals to 1 to C Ni Vi Ig. SIGM summation I equals to 1 to C Ni Si bar IgM equals to I won't write automatically here, something will happen here. Knocks up. Any comments? The answer. You know the answer. Si bar Ig is what? Si Ig plus Rn and Xi, right? Minus Rn and Xi. So what will actually happen? Summation I equals to 1 to C Ni Si Ig then minus summation I equals to 1 to C Ni Rn. What will actually happen? Delta S IgM not 0. It is not 0. Delta S IgM is what now? Earlier case I think so because it is quite obvious there is 0. I don't want to show. Delta S IgM is not 0.
Minus R Ni then Xi.
It will be minus NR summation I equals to 1 to C Xi, very compact form, minus n into X is NR, right? Correct? Correct? Is Ni is there. Similarly, can you have expression for delta GIGM, what will happen? Like that, similar type of expression I want from you. Similar type of expression I want from you. Similar type of expression I want from you. Yes sir, you should participate. NRT summation I equals to 1 to C xi over. And that term summation xi and xi cannot be 0. So that's why delta G IGM, delta S IGM cannot be 0. Impossible. Okay. So now we have got well equipped to go for departure function. Now we have got well equipped to go for departure function. We start thermodynamic departure from mixture. Departure function for mixture. What we do? We calculate HT2P2 minus HT1P1 mixture. Generally, when you calculate enthalpy, we don't talk about the gas, argon, or oxygen, whatever. We say gas mixture. That's why when we talk about the departure, we talk about mixture. We can always talk about individual component. It is not useful in chemical engineering. When you take some sample, when you measure temperature and pressure, we always talk about enthalpy. Humid air has the component water and air, dry air, right? Bone dry air and water, two components. When we talk about the enthalpy, we don't talk, okay, this is the enthalpy for bone dry air, this is the enthalpy for water. We talk about humid air enthalpy. That's why we talk about the mixture. Okay? We won't go for the individual property. You can always calculate, you don't do after use. Okay. The same way you can calculate. So this will be giving you delta H. Similarly, one can calculate UT2P2 mixture minus Q mixture P1 P1. So what will you do departure function? I am teaching from TP plane. TP plane you can do the same way. I am not doing TP plane. This is your P. This is T. This is P1 T1. Go like this. And this is your P. Same diagram. Same diagram. Any thermodynamic property. Delta M mixture will be what? M T2 P2 minus M P1. Same way. So far everything is same, no difference with pure substance. So far everything is same. Next step. 3 steps, right? Tell me the 3 steps formula. Next, you are there in your book, pure substance. You have the pure substance ready, then everything is done. Pure substance. This is, remember that this is P3 into 0. P3 into 0.
Sir, integration.
Integration.
P tends to P1.
P1.
P1 to
P tends to 0.
Dou M mix.
Dou M mix.
By dou P.
Dou P at constant T1. dP
plus
T1
T2.
T1 to T2.
Dou M mix by dou T.
Dou M mix by
Dou T.
dou T.
And constant P tends to
0 dt plus
P tends to 0 to P2.
P tends to 0 to P2.
Dou M mix by dou P.
Dou M mix by
Dou P.
dou P at constant T2
to dt.
So far, pure substance, multi-component substance, no difference in departure. Next step. the definition? Do you remember? Pure substance.
Integral P1 equals 0 to
P is equal to 0 to dou m dou p T dp minus P tending to 0 to P dou m Ig by dou p T. For gas mixture, it will be IgM. Tp, which is P tending to 0, P dou m by dou p dp minus P tending to 0 to P dou m IgM by dou p T. So far similar, no problem. So far similar. Delta Mx, next step. I want you to write in terms of departure. Quite obvious, because now departure function has been defined for the mixture. The departure function has been defined for the mixture. Departure function has been defined for the mixture. You can write here IgM. Sorry. Yes, go ahead, mix everything is there. Yes, who will volunteer? Devayan. First term.
So M minus M means
What is that first term? You have the notes with you, right? Okay. Follow the notes and tell me. You should have the notes. I am not asking something which is not there. You are not having the notes, right? Yeah, please go by the notes. Don't be lazy. If you are lazy, you won't learn. Don't be lazy. You have the notes. Your substance is there. Notes are there. Look at the notes and tell me the answer. Don't tell the answer? Yes. Minus, yes.
M minus MIG.
M-I-G-M? Yes, M-I-G-M.
Minus.
No, you should write T1, T1. It is there in the notes, no? Yeah, why are you not saying that? Yeah, then
Minus.
not minus. This should be, this term will be coming, no? Next term will be coming. T1 to T2.
M minus MIG. IG.
T1 to T2 will come. Dou T of M mix P tending to 0 dt, then plus M minus MIGM T2 P2, then two more terms will come. Minus P tending to 0 to P1. Don't try like a mugging. Think what you are telling. Okay, next. Dou MIGM, yes. Dou P constant P1 dP, then plus P tending to 0 P2 dou MIGM dou P P2. Agreed? So far, pure and multi-component formula is similar. It will differ now. So far, pure and multi-component you can see same. Even you can open your pure substance book and tell the answer. Right? It will differ which term. I proved previous beginning of the class, departure formula won't change. So don't say it will differ. Values will be different, A and B, but formula is same. This formula is same. This formula is same. This is. So we'll see that. We'll see these things what actually happen. So we'll take very complicated one. I won't say U and H. I will take S and G. They are all varying with temperature and pressure. So we'll say now. We'll pick up SIG. I didn't find like this any of the books. So this is purely my notes. So if you don't follow, there's a problem because I didn't come across any books in this one. M is equivalent to S. I'm taking entropy. SIG. What should I write? Because I have to calculate these two and this. When I put SIGM, so you have to know dou SIGM by dou PT1, dou SIGM by dou PT is integration part, and also this dou rho T of S mix. So first you write what is the expression for SIGM? SIGM. What's the expression for SIGM? Summation I equals to 1 to C Ni Si Ig minus dou SIGM. If M is replaced by S, it will be dou SIGM by dou P at fixed T. Dou SIGM by dou P at fixed T. What will come?
Say Ni R by P.
Summation. You are not writing. Excellent. Very good. Summation Ni R by P. All of you got it? Yes. Because SI Ig and this one actually, if you take the thing, you have the expression, and from that you can actually get it. Okay. And why it is R by P? Because dou Sig by dou P at fixed T you know, which is R by P, right? Cp by dou Sig what is that? We say way R by P, so I want to write the steps. It will be summation I equals to 1 to C Ni dou P Si Ig at fixed T, and that will go because not a function of temperature equation. What is this term? Dou Sig by dou P at fixed T and dou Sig by dou P at fixed T. You told the answer. Let me this answer.
R by P.
No, it is not R by P. Dou Sig by dou P at fixed T. How much it is? How it is coming R by P? How it is coming? Check back your substance. Yes, beta. From beta it is actually coming. The ideal gas is coming. That's what I am actually asking the answer. And it is coming minus R by P. Am I correct? Dou Sig by dou T at fixed P. How much it is? What is that? Cpig by T. So what is delta X mix? You have the expression, you will be the answer. Delta S mix. Formula is minus S mix minus SIGM T1 P1 plus do you agree with me or not? Yes? Rahul? Yes? You didn't get. See, that's what. Since Devan is saying yes, you are saying yes because you feel. That's what. Since I asked you, that's what I'm saying. Devan, can you explain? You said yes.
1 by n part I didn't see it. 1 by n.
That's what you are saying yes, just like that. No, that's what. No, don't argue. I don't argue, right? How will you get it? What second term is T1 to T2 dou M mix by dou T at fixed at P tending to 0 dt, right? At P tending to 0, any mixture will go to IGM, right? So that means dou T of S IGM P tending to 0 dt. What's the problem? Second term. What is the second term? In the delta M, second term is T1 to T2, right? Dou M mix by dou T at P tending to 0 dt. P tending to 0, any mixture will be ideal gas mixture. That's why it is IGS. The simple thing to not understand. It was S mix second term. Second term is S mix. You replace M by S. You replace M by S. Since P tending to 0, then only you can write SIG. Next step. Next step. I want a final answer. I will complete this. What will be this term? Last two terms, any idea? Last two terms. Remember the capital X, M is the extensive property. That's why I am putting 1 by n. Correct? If I write in terms of small, we have to write 1 by n. I am not putting capital. If I put capital S, then 1 by n will not be there. Then tell me the answer. Last two terms, what should I write? Last two terms, what should I write? Why is so much of confusion? You have the delta m formula with you? Delta m formula in the departure from, what are the last two terms?
Minus
P tending to 0 to P1, dou m IGM by dou T, P dp, right?
yes.
Yeah. So what will be your replacement? What is that? You are actually confused. You have to just read out from the notes, and that you have to struggle so much. Now I am feeling very tired, because of you guys. Almost like more than an hour I had to talk repeatedly to get some answer from you. If I don't get answer, at the end of the day you won't learn anything. I am just asking you to repeat what is there in the notes, and you are not able to get it. You have to just replace by M by S. What is that? What is that? You can't replace M by S. Yeah, then you can't tell me. Is this the way I will tell in the class? Sir, do SIG and finish it off. I can do that and go home. I won't actually sweat. If I talk like Devan, I will be really enjoying life. I will not sweat out. At the home I will be really fresh. I can do more research. I won't talk like this. Don't look at his notes. If you don't understand, everything is written. If you don't understand, please ask me. I am there to help you. If you are seeing his note, he should come and teach. I will sit in his place. Integral terms are all. Yeah, you won't tell all those things because you don't care. Integral, without integral, everything will be the same. Yes, integral.
P tends to 0 to P1.
Yes.
Dou SIGM, IGM.
Yeah.
By dou P at constant P1.
Yeah.
Dou D.
But that was that formula has been talked about, was talked about in terms of extensive property. So what should I do? Why? Because I have to get in terms of SIGN. Yes. Similarly, plus 1 by n, p tending to 0 to p2, dou SIGM by dou p p2 p. I am saying this is my integral I1 and this integral together I2. I have developed I1 and I2. Then my job will be done. What will be I1 and I2? What will be I1? 1 by n t1 to t2 integral dou t. SIGM formula is available. SIGM formula is available or not?
Yes, sir.
Yes. What is the formula?
Summation of
Summation I equals to 1 to C Ni SIG minus summation I equals to 1 to C
Ni R
minus, you can just put minus NR Xi ln Xi. Correct? Yes or no? Convinced? Next step. Dou of this term is 0. Nothing is there, no temperature, only this term will matter. What will actually happen? Ni dou Sig by dou T. Okay? So dou Sig by dou T at fixed P is what? Cp by T. Yeah. So what will be the final expression? Summation I equals to 1 to C fill in the blanks. Before integral what will be there? After integral what will be there? T1 to T2. T1 to T2. T1 to T2. What is that? Why so much of confusion? Everything is done, but dou Sig by dou T, Cpig by T, that's it. Then what is the formula?
Cpig ln T2 by 2.
But Cpi is generally a function of temperature. Yes, I put T integral, that means ln should not come down. See, look at the board. What I am expecting the answer. Cpi is generally a function of temperature. I won't say Cpig ln T because Cp is not the function of Cpig is always a function of temperature. You don't generally take constant for the gaseous substances. What is the answer? Before integral, what will come? Before integral, what will come? Rahul? Before integral, Ni will come? Any answer from your side? Xi. Then? Cpig, Ig, E, and Cpig is a function of temperature. The function, you know that I have discussed already, A plus Bt plus Cp square plus Et to the power minus 2. The function of Cpig temperature. These things are available in the books. I2. What is I2? Minus 1 by n, P tending to 0 to P1, rho P plus 1 by n, P tending to 0 to P2, rho P. You have to write in the formula of SIG, which is nothing but summation I equals to 1 to C Ni SIIG minus Nr summation I equals to 1 to C Xi ln Xi summation I equals to 1 to C Ni SIIG minus Nr summation I equals to 1 to C Xi. One is at T1, one is at T2. The answer should be very quick. This has no function of pressure. It will go only this. That means dou Sig by dou P at T1. Second term will be having dou Sig by dou P at T2. What will you get? What will you get? Dou Sig by dou P at T1 is R by minus R by P, right? Yes, give me the answer first. Who will give me the answer? Any answer is ready? Any answer is ready? Yes, madam. Minus summation I equals to 1 to C Xi then Xi after minute of Xi R will be R won't come. That's why you unless I press, that's the problem, you know. You don't care when you give me the answer. R ln. Yes. So what finally you got? Delta S mix minus SIGM at T1 P1 plus summation I equals to 1 to C Xi T1 to T2 CPIIG by T dt minus R ln P2 by P1 plus S mix minus SIGM T2 P2. Correct? These two terms coming from I1 and I2. Now compare your pure substance expression. Where it is different. Delta S you have calculated the pure substance, right? Yeah. What's the difference? These two terms will be same. It differs here. Why it differs? This was minus Rn ln P2 by P1, no Xi will be there, and it is Cp by T dt. only the summation of xi is coming external. Otherwise, the entire formula is same. That is the departure function for the, and you can do it for the, I have done for the entropy, the toughest part. You can do for the enthalpy, you can do for the internal energy, displacement energy, and so on. And that's the way we can derive the stuff. Okay. So we'll now slowly introduce, before I will finish within 2-3 minutes, but I will give you a thought, pattern of thought for the definition of fugacity. So fugacity for components in mixture. Fugacity for a component in mixture. Pure component, you have the definition with you, right? Which is f p exponential mu minus mu ig tp by RT. Am I correct? Mixture, which is Fi mix Pxi exponential. What should be the term? Fluid mixture, pure component, you know, I am explaining the fluid mixture for individual component. And why I need individual component mixture? Because when you talk about the pressure, you talk about the pressure for overall pressure. Partial pressure you don't partially talk. But when you talk about the multi-component, multi-phase equilibrium, we will see that fugacity of each component matters. We derive that part. Thermodynamic equilibrium for pure substance. Thermodynamic equilibrium for pure substance. Conditions are P1 equals to P2, P1 equals to P2, mu1 equals to mu2. It gives fugacity of first phase, second phase. Multi-component substance, P1 equals to T2, P1 equals to P2. I will prove that not the fugacity of individual component has to be equal. That I will prove. And based on that, we need to have the fugacity of ith component of mixture to be defined properly. How to define that? How to define fugacity of the ith component? Yes. Mu I bar is not defined. You don't say mu I is IgM. Mu I is nothing but Gi bar. We don't say Gi bar. Why do you write Gi bar? We write in terms of mu, no? I think we are really confused in the symbols. Do we write mu I bar? We never write mu I bar, right? Mu I is nothing but Gi bar. Mu I is nothing but chemical potential of ith component in a mixture, which is equivalent to the partial molar Gibbs energy of ith component in a mixture. Mu I is nothing but chemical potential of ith component in a mixture, which is equal to the partial molar Gibbs energy of ith component mixture. That's why it's called mu I equal to Gi bar. Yes, what will be the formula? Mu, you are right. It should be mu I minus mu I IgM Tp x will come. So we'll take up this formula next and proceed